All right, guys. So about our next speaker, I learned something recently about him, and that is if you say GraphQL out loud like 3 times, our next speaker is going to appear next to you, and he's going to teach you all about it. And he's also a true programming nomad. He's got like 30 things that he fits in this backpack. That's what he calls his home. And he travels around the world with it. He doesn't rent a place, he doesn't own a place, and he hasn't stayed in a single country for more than 2 months in the past 4 years. And during this nomadic career, he ended up working with this awesome Meteor development group, where he got a lot of opportunities to work on open source projects regarding GraphQL. And now he preaches and teaches about GraphQL every chance he gets, including this one. To tell you all about GraphQL and the BFF architecture, here is Yuri Goldshtein.
Hi, good morning. So I'm Uli, and I'm, like Prashant said, I'm a nomad, I guess. Before it was called Nomad. But even before I joined Meteor, I used to do a lot of open source development. And during that time, I started this group that you're probably asking yourself, what is the guild? I started this group of open source developers, and we are kind of like, my goal was to create a group of very strong and smart people that can have the freedom and the financial means to develop open source as much as they can, without VCs, because a lot of companies that do open source, they have investors, and then the way they do open source is in order to publish something. So we do open source without publishing anything. We just do open source because we think it's necessary. And you probably know, this is, I think, the first time I actually put this out there, the guild, because you probably heard a lot of individuals of us. You heard them individually, and that's the point. The point is the guild is not a company. It's just a group of individuals that work on open source. You probably use a lot of our libraries every day. So that's a bit about us. I just landed yesterday night from San Francisco, so I'm a bit backward, so I hope I won't die. But that's why I think what I'll do today is that I'll start with like a very short introduction of GraphQL, because probably there's always some people who still haven't used it. And then I'll talk a bit about the vision, or like what you can actually accomplish, or what we try to accomplish with it. And as fast as I can, I'll go to Q&A, because otherwise I'll fall asleep, and you too. So, so let me start. That's my girlfriend. She's the boss. So the talk is called BFF. BFF is the backend for frontend. And that's, I guess, the most common use case of people using GraphQL. You get like a set of, you work as a front-end developer, you try to get data from all kinds of backends. Usually they're shitty. They don't give you the data you want. You don't know how to get the data you want. They're going to do it slow. They're going to break on you. And GraphQL brings you that middle layer that basically makes your life as a front-end developer much easier. And that's fine. And probably, maybe before that, how many people heard about GraphQL with a raise of hands? Everyone, great. How many people are using GraphQL in production? Much less. How many people wrote an app in GraphQL? More, OK. So probably most of you, so that's why I'm going to skip the intro. I'm going to do a short intro, but then I'm going to talk to the what you can actually do in GraphQL, and how even if your backend currently is not using GraphQL, you should start using GraphQL right now on your own part of the code. You don't need a GraphQL backend to use GraphQL. Yes, so GraphQL is a query language. So like we said with the BFF, like the most common use case is that you create a schema of your backend, then you send a query and you get exactly what you expect. No more, no less in one single round trip. That's cool, but you can take the same thing and apply it to anything, any type of data. It doesn't have to be over the network, and it doesn't have to be over REST APIs. It can be on anything. You can create a GraphQL database. I don't recommend it, but there's companies who do that. And you can use GraphQL on your front end to handle data and to handle your local state, and we'll get to that as well. More than that, I just came, as I said, I just came in from San Francisco, where there was a talk from a guy from BMW, where they used GraphQL for all the car data, the live car data on the car. So you can select a GraphQL query to tell you if the window is open or not. And you can create a GraphQL subscription to get the current speed of the car, or whatever you want. So all the data of the car is running through GraphQL. So that's just an example that GraphQL, where you hear people talking about over the network, that's just one use case. And GraphQL is growing very fast. Like just last week as well, the Linux Foundation just embraced and opened a GraphQL Foundation. And in the foundations, there's companies like Netflix, Airbnb, GitHub, PayPal. A lot of them are clients of us as well. And there's a lot of people here as well that we work with that also in very large companies that use GraphQL in production. So just talk to your colleagues. So a brief introduction of how GraphQL works. Because everyone is like just talking about this magical thing. What's actually happening? So the first thing I need is a schema of my data. And you can see here I've just created a schema. It's a pretty simple schema of a user and a message. And they have relations between them. Now, what would usually happen with REST APIs or something like that is that I'm going to query the user and the user's messages. I'm going to get back a bunch of IDs, and then I'm going to query back each of those messages. And I'm going to send like a lot of requests over the network. I'm going to get data from the REST APIs that probably I don't need. And there's a chance that also the type of data will change with time, so it's going to break my front end. But with GraphQL, I can just describe what I want with a query, send that query. This, let's call it a GraphQL engine, will query the things that I need from a specific endpoints and will send me back one single result that looks exactly like my query with the right types. Now that's great, but I can even ask for more. I can ask for each user, I want to get the messages. And the messages might go from a different database or a different source. And again, this GraphQL, all I need to tell GraphQL is how to fetch the messages or individual message, how to fetch a user, and GraphQL will do the rest for me. So on the client, I don't need now to wait for multiple responses. I don't need to shape the response since I got there, to run a map over them and then put them in the UI. I get in one single response exactly the shape that I want, exactly the shape that I want to display in my UI. The main thing here is that probably a lot of the code that you have currently in your front-end apps is code that sends a bunch of REST requests, wait for them, make sure all the requests is got, then like iterate over over this information in order to like build it kind of like how your UI is shaped. And then you render it. All of that code is gone. You just don't need it. Like, people don't understand. There now just was a blog post from PayPal that also moved to GraphQL, and there's a quote there saying that like 2/3 of the time of a front-end developer is being spent on those stuff instead of like actually rendering your UI. So this thing is gone. And it sounds weird, and it's just gone. Now, one more thing that GraphQL gives you is that it gives you type safety. But it gives you, like maybe some of you are already using TypeScript, and you're like, yeah, cool, TypeScript is really helping us and everything. But you don't get type safety. So you get type safety with your own code or your own team on your front end. What about the types, the data that you get from other teams or from other sources? You don't get type safety there, and this is actually where you want your type safety. This is actually the code that you're not controlling. So with GraphQL, you get type safety over the network. So it doesn't matter if your backend is Java or .NET or whatever, you get this. You get inside your editor, you get autocomplete, you get validations, you get everything you would want and you would find useful with TypeScript, but over the network, over code that you never own and you might never use. And you might never know actually who writes it and how. So that's very, very powerful. Then you can take this type safety and actually use it with code generators. So from the guild, we wrote the GraphQL code generator. If some of you used Swagger once, it's based out of, the idea was based from the Swagger code generator. You can generate anything from GraphQL. So I'll just give you a short example. Yes. See my emails and everything. Yeah. So this is just the website. It's a new, it's a very popular library, but we just opened the website recently. But I don't know if you can see here, we just added this. So you can get a schema, which is what we said. You just describe the schema of your backend. Then you write some queries, because with GraphQL, you also know what the client needs. So you can write some queries. You can choose whatever templates you want, and it will generate here whatever you want. In this case, it will generate GraphQL TypeScript over your client. So you get types of the responses that are going to come from your network automatically. You don't need to write types, your TypeScript types ever again of your backend. But we can also generate the backend. So the backend also, if you write your GraphQL let's say your GraphQL server in TypeScript, you don't need to write the types. We can generate them for you from the schema. We can also generate, if you're using React or Angular, we can generate a ready-made React components that are completely typed. Because we know the query, we know what you want, and you know what you're going to get. So just get a React component or get an Angular component, an Angular service that is ready-made for you just to use in your component and fetch the data. And there's more. Like, you can generate whatever you want, basically, and that's the whole point of this generator, that you can generate custom stuff. You can just see here more things, but this is just the start. OK. So this is just an example of things you can do. You saw that already. Another thing is real-time. I'm just mentioning it because it's a very dear subject to my heart. I was part of the team that worked on the GraphQL subscription spec with Facebook. And the important thing here, after working in Meteor for a while and really advocating for real-time and why is it important for your apps, but still nobody uses that, I realized that nobody has a reactive backend. Nobody can write their backend from scratch. So what if we could have the simplicity of building real-time applications over whatever backend you have? It can be like an old IBM Sphere whatever. It can be like a REST API. It could be whatever. And that's exactly what we've done with GraphQL subscriptions. The idea there is that we take GraphQL, and we basically use GraphQL over pub/sub mechanism. So I can just create an event. That event can be triggered from anything that I can think of, and then I can describe this event, what data can it give me. So I can, on the client, say, OK, I want to subscribe to let's say I'm writing a chat. I want to subscribe to a message added, and I want to get the content and the author. So now an event will fire. That event can be triggered from anything. It can be like a regular message that, a regular function that someone created to message edit. I don't need a reactive backend. And then I will run the GraphQL engine again. So even if this event doesn't hold the let's say, the author information, I will still, the GraphQL engine will query the extra source and will enhance the message and will send back the client exactly what I was expecting to, even if the data source, again, is not reactive. So I can build real-time events and real-time apps over completely static data sources. And that was the important thing. And then what we're working on now in the guild is about live queries. So I won't touch too much about that subject, but that makes it even easier. I gave a full talk about, like 40 minutes talk about just the difference between subscriptions and live queries, so I won't do it now. But what we're working on now is basically Firebase, for example. A lot of you probably are using Firebase, and it's great. It's super simple. You just get a collection into your app, and it's live updating, and it's super, super simple. But still, this collection, you need to now handle it on the client. You need to iterate over the collection and display it on the UI in the shape that you want. With GraphQL, you don't need even that. If you would build live queries over Firebase, you would just put this query into your component, and that's it. The data will be in the shape that you want, will be live updated all the time without you doing anything. So we're working now on this. So that was GraphQL that was basically some of the things that GraphQL can do. But what I'm really interested in, and people are not super aware of, or not as aware of as they should have, is that you can use GraphQL on your client without having a backend at all, and you'll still get the benefits of GraphQL. So I'm going to skip this, actually. So what if we had this GraphQL engine, like you saw before, but just on the client? This case is Angular, but you can put React or anything, or Vue or whatever you want to put in there. But what if I had GraphQL over my Redux store or my NGRX store? How would that benefit me? So this will benefit because, first of all, you don't need anymore to learn some kind of a language to your backend and some kind of language to your frontend. Data is being described with one language, and this is GraphQL. We haven't found a better language to describe data yet. So why do we need to learn Redux now? Also, with Redux, it's basically a blob of information. And then, again, we need to manipulate it somehow. We don't know the types of it. What if each component, instead of just the whole client as a whole, each component will actually write the types and the data shape that they want, and then when we render the whole page, each component will query the data that they need, and will get the data that they need. We don't need to manage services. We don't need to manage a local store. We just need to manage our components. No need for central code or central anything. Each component can describe what they need, and that's it. So let's see how it happens. So I can actually send a query from each component, and this query will run into my local engine. Some of the data will go to my Redux store. Some of the data will go to my backend. And at the end of the day, my component will get the data that it needs, just the component, in each of the components on the client side. Even if I'll query a third-party thing, like a third-party API, I still will get this data into my specific component. So I can start really, when people are talking about micro frontends, they talk about just the front end, just the UI, but they forget the data. And if you look at Facebook, how Facebook manages I don't know, endless amounts of UI components, and that's why they invented React and why they invented the Flux architecture. is because that in Facebook, you truly get front-end micro apps. You truly get components that are encapsulating not just their display, but also their data. And this is, if you really build front-ends at scale, this is how you should manage your data, not Redux. And you see now companies all over the world. I told you just I came back from like conversation with PayPal, with Netflix, with all those types of companies. They're all just slowly ditching Redux into moving into GraphQL client side. More than that, if we'll take that concept of using GraphQL client side, then what happens if I have a REST API? Well, I can do the same. I can just use GraphQL just on the client side, each component will describe what they need, and then the source that I will send over the network would be to a REST HTTP server. That's not a problem. Then I can start actually using GraphQL, get all the benefits as a front-end developer, as a product engineer, while still, let's say, talking nicely to my backend developers who doesn't want to learn new technology. Yeah, I'll skip that one. So just for that, we actually released, so the reason I'm here and I'm going to do it mostly QA is because a lot has happened last week. I came from San Francisco and just asked the guild, we released like 3 new open source libraries. One of them is called Luna. Luna is basically a library that you can use just on your client side. You can replace it today. You can slowly, you don't need to replace everything, but you can component by component replace your Redux or NGRX or whatever you use to use your local state management system with Luna. And it's basically a wrapper over Apollo client, but it gives you all kinds of things that it's kind of like taking the best ideas from Apollo and GraphQL and adding some ideas like middlewares and actions from Redux. So you can check it out. And why do I put this slide up? Is because what I see more and more is that like when we go to clients or we work with people, at the beginning we just start talking to the front-end developers, and they're like, they get it. They get what GraphQL is so great and why it's wonderful for people building products. But slowly, as GraphQL grows in the organization, the backend teams start to get it. And GraphQL makes, I think, in my opinion, much more sense on the backend. And as a backend developer, I think GraphQL has a huge benefit of organizing your backends. And what we see more and more, like I gave the example of the guy from BMW, but more and more companies are actually starting to slowly merge all of their microservice and all of the data inside of the organization into one single GraphQL endpoint. That's what we are all going into. So, and that's the real benefit of GraphQL. Like, this is how Facebook uses GraphQL. In Facebook, you have one single endpoint that describes all the data that Facebook has. And then you can build products, you can merge products, you can try to bring this data from one department and data from another department, and all this data is declarative and self-describable, so you can even build automatic tools to generate things over your organization's data that you never thought were possible. So now we're in the, let's say, 3rd or 4th year that GraphQL is open source. We started to see more and more companies that do that. And more than that, we're starting to see companies that take public data from all kinds of different sources and merge them into one. There's a company called OneGraph. You can just open Graphical. This is the GraphQL editor, and query whatever information you want in exchange, and it is merged together. For example, you can take all the restaurants from Google and give them the rating from Yelp in one query. So think about whatever organization you have today, think about what will one graph of all your organization would look like and what you can do with it. So another thing we open sourced last week is a library or a framework called GraphQL modules. Some people in the audience already use that. And the idea here is that when you get into such scales, you want to think about how do I actually separate my backend into small modules. And more than that, in modules that I can reuse. And each module has its own GraphQL schema that describes it. So when I install, for example, another module, it just extends my schema. So now you can start not only having one graph of all your data in your organization, you can also start to have like reusable modules from your organization, reusable code that once you just install that, it will extend your schema. And if we'll take both of those concepts into the world, now you can think about something that's we used to call many years ago the semantic web. What if all the data in the world will be described by one GraphQL endpoint? What will happen if you have one endpoint that you can query all the data in the world, and you can create an automatic browser that just looks at the data and renders whatever you want. So you can query for news stories from all the different newspapers about one specific subject, for example. And GraphQL modules is like the step over it, so you can even install NPM modules, for example, authentication. We all have a user, an email, and password. And what if we want to add a Facebook login? We've done it 10,000 times. What if we can just install a GraphQL modules that hold all that logic together, and it will just extend our schema, and that's it, and it will work. So that's GraphQL modules. That's kind of like a very fast overview of everything that I've, kind of like very short intro of what's possible, and I would really prefer to answer questions than just show stuff. So this is just the start. So now to you. Ask questions. I don't know, I saw that you have like small microphones and like in the UN, so. Yeah. I dumped a lot of information about you, so questions, please. Yes. Can you open your mic so people can also hear? I have no idea how you do it.
This works? Yeah,
Yes.
Okay, this works, great.
It's like the UN, we can do discussions and like voting.
Can you tell us something about performance? Because you talk about merging a lot of different data sets.
Yep.
Some of these would respond at different timings than others. How does that work?
That's a great question. So one thing that people sometimes forget is the core ideas of GraphQL. The core ideas of GraphQL is, unlike, let's say, REST, is that the client describes what they need. So people think it's just data. But that's not always the case. Like, you can do more. For example, with this query of giving, let's say, give me, for a user, the name and the age. Now, like, what you're asking is, like, what happens if name comes from one source, names comes from a different source, and age is super slow. What does it mean? It will mean that the name will come slower, right? Like, the name will wait. So what GraphQL gives us is tools for the client to describe what they need, meaning the client can say, you know what? You can put a defer on maybe I'll demonstrate later. So you can put like annotate the age with a defer annotation, which means the client basically says, look, I want the name and the age. If the age comes later, I'm fine with it. Just send me the name, and later on send me the age. What will happen on the backend? The backend then has the job of deciding what to do. If the backend can't support 2 requests, it will just wait. It will wait, and once the slowest field will be there, it will send it back. But the backend, if the backend supports all kinds of different transports or all kinds of different mechanisms, then the backend can send the name first, and then send the age. And there are already implementations for that. But that's kind of like, what's happening here is that you give the client tells the server that it's okay to to send the age later. If you would do it in a different implementation, the server would never ask the client if it's actually OK or not, and the client will have nothing to do with it. That's one thing. Another thing in terms of performance is that a lot of people are talking about caching when it gets to performance. And with REST, you can cache the whole response, right? Like you can take the name of the whole query, the name and the age, and you can query the whole thing, and you can do the same with GraphQL. With GraphQL, you can take it one step further. You can cache the field level. So you can say, look, age just doesn't change so often. So I can cache the field level, and then even if there will be a different query with an age and books and whatever, and the age, then it will be cached from whatever query you want. So the caching capabilities are much stronger than REST. I'll add more into that is that when you do monitoring and performance monitoring, you can get kind of like performance not on the all query level, you can get on the field level. So you can find your bottlenecks much easier. So usually when you do that, when you start the way we do it in organizations, we put in a GraphQL API. Then very quickly we find the bottlenecks, and then after an hour of work, like just by running those fields in parallel or just by caching them a bit, you get far more superior performance than what you had before when you did fine-grained manually performance optimizations. And I'll add one more thing, that again, you get, with the request, you get what the client needs. So let's now imagine that we don't have a REST API, but we're querying a database. Today, if in a regular server, we would just assume what the client needs. We would assume that the client needs all the fields, and we'll do a query for the database with all the fields. With GraphQL, I can even get the AST of the request, and then translate it into a much more optimized SQL query, where I query with the SQL just what I need. So, good question. Yes. Oh, no, you don't have a microphone.
So with GraphQL, that's nice. That's better. So with GraphQL, you have basically, in terms of CRUD, you only have the read part, and you can make functions to do updates and deletes and stuff. Would it be nice? I'm not sure if is there a vision for using the same model for the whole CRUD operation instead of only the read part?
So you do have CRUD operations. I don't know.
You can make separate, I'm not sure how to call it, but kind of endpoints or functions that you can post as a query with some data that you want to update. But it's not the same model. Well, you use the types of the model inside these queries, but it's not like you cannot like say, okay, these. So I have a user and name and age are not changeable, but username and email address are changeable. So I can just, based on that type, I can do an update without having an extra function to do that. Yeah,
I understand the question. So just maybe a step backwards. In GraphQL, you have queries and mutations. Mutations are basically a bad name for actions. Kind of like, let's call it post request in REST, right? So you can send an action, and that action can do something, but it also can return data. In GraphQL, when you describe a mutation, you also give it a schema. So let's say in REST that I'm creating a user, I might get back from the server 1, true, nothing, who knows, 200, I don't know. In GraphQL, you have a schema, and you can ask back, for example, the new user. So I created a user and can get back a new user, and I can expect that. I know what I'm going to get. What you're asking is, if I have a user type, can I already automatically create a CRUD operations over that user type? That's a great question. We deliberately didn't put it on the spec because actions can be arbitrary. But there's many tools that do that, that does that. Like there used to be a backend called GraphQL that basically you just describe the schema, user, and everything, and it generates all the CRUD operations for you. And there's many, many tools about that. What we did as the guild, because we work with like a lot of very large clients, we know this thing is good for like when you start an app, very quickly it doesn't scale. But just because we were a bit pissed about all those solutions that are generating that in a very simplistic way, we created a template in GraphQL CodeGen. So you can automatically do that today. You just write your schema, we will generate all of that for you. I presented it in like a conference talk, I think a year ago or 2 years ago, where you can just write a schema, annotate it a bit, and it will generate a complete backend for you. Like in whatever backend you want. You want Mongo, you want Postgres, SQL, whatever you want. So it's true to expect it, and you can generate it, but I think it will be wrong to include it in the spec because most actions are not simple CRUD operations. Like it's good when you start, very quickly you understand that you need other things, you need custom logic, you need all kinds of very weird action, but it's definitely possible, and maybe and there's many solutions that gives you that. For example, one of the nicest one that I saw last week is named Hazura. So and there's also PostGraphile. So basically, you just describe in Postgres, you just build your SQL schema in Postgres, and it generates a complete backend with all the CRUD operations for you with GraphQL. So if you want to start very quickly, I would recommend use Hazura. Yes.
I have a question regarding one of your open source project, Luna.
Yeah.
Where does it exist in this ecosystem? Because we have something Apollo already on a client. It has a store, and then the Luna comes in. How does they exist? What's the layers in there?
So when I started talking about, that's a good question. When I started talking about GraphQL on the client, that basically means that instead of just sending this query string over the network, you can basically start sending those query strings from the components themselves. Then it means that there needs to be something central that will merge all those things into one place and then will distribute it back again. You can think of it as like just a client-side GraphQL-based database. And there's two main ones. One is called Apollo Client, and one is called Relay. Relay is by Facebook, Apollo Client is by Apollo. So we build Luna on top of Apollo Client, basically to add more interfaces and to make the work of working with this Apollo Client much easier, and gives you not only easier, gives you more options. For example, if you want to build an offline first client, like that you can do all the actions offline and then sync later, or all kinds of things that you would expect or you are used to when you use Redux, you can get the same with Luna, but it's basically just an extension of Apollo Client. We're thinking now about maybe making that as an extension over Relay as well. But that depends on the Relay people and what do they think about the future of their own project, which is a different question. Yes.
Over here. All right. So this all sounds great. It's like, hallelujah, this solves all my problems, right?
Yeah.
There must be some like pitfalls or like some challenges while implementing. Can you name some of those, maybe?
Yeah. It's a good question. So I guess with great power comes great responsibility. So I will say, first of all, I see GraphQL as it wasn't that I started from GraphQL. Like Prashant said before, I started before in C++ and .NET and stuff, but when I came to the web, I started with Node and then Meteor. And Meteor was this like all super great, like everything you want, and nobody used it. Why? Because Meteor expected you to rewrite things. It was very not pragmatical. It's like, okay, you need to work with Mongo. Or if you don't need to, you actually could work without Mongo, but not a lot of people knew that. GraphQL is a very, very pragmatical solution that came from a pragmatical approach. Facebook, in 2011, used GraphQL because in 2011 they had an HTML-based app. And Google just released Google+, which was far superior, was a native app. They used gRPC from Google. It just worked much better. And everyone was like, okay, Facebook is dead. Like Google+, like it's going to destroy them. Sounds funny today, but that was the case. So they had, and Facebook has a really, really shitty backend in a language called Hack, which is basically PHP compiled to C++. And they used to send HTML over the wire. So they did a solution that will be pragmatical, but good. And everyone is talking about, in that time, everyone was talking about the HTML5 versus native apps, and that native, like HTML is dead and all of that. What they forgot is that, or they didn't publicize, is that the biggest thing that changed was the GraphQL over HTML. Why am I saying all of that? Because constantly, as like someone who's been there from the start of the open source of GraphQL, we try to make it very pragmatical, extremely pragmatical. Like he said, and that's kind of like the downsides of that as well. Like you are relying on the industry to create like an out-of-the-box great solutions. The protocol itself is very pragmatical. You don't get a lot, and that's on purpose. But that means that you can build, you still don't have a Firebase of GraphQL. You have some, but they're lousy. Sorry to say, that's my opinion. I hope I'm not, probably I'm recorded, whatever. They're lousy. They're really lousy. But, and I can say it from coming from Meteor. I forgot what I want to say. I got stuck with the lousy part. Yeah, but that means that, like I presented before, and I had a whole talk about it, you can do real time over your shittiest backend that you can think of. I don't know. One of the things is that's why I like to do the Q&A. I like people to attack me and say like, this is not good for this, or this is not good for that, and I always have the answer. So I'm kind of like. I'm kind of like, and it's a problem because when you go to convince someone, again, I'm from the guild. I don't care if you use whatever you want. Like, I'm not selling a product here like Apollo. But when you can't tell anyone, like, look, this is the problem, then they don't believe you. But I haven't found a single case where REST is better than GraphQL. A single case. Other than people are not being educated about what you can actually do with GraphQL. But that's not because GraphQL is so smart, it's because REST is so dumb. Like, REST was kind of like a poor child of history. We came from SOAP, where we were like, okay, cool, we can define contracts and or gRPC, we can define contracts between each other, and then there was REST. Like, the contract was like, send whatever the fuck you want. I have no idea what I'm going to get. How was that even like a good idea? So it's not about like GraphQL being smart. It's just REST being like a weird child of history. So, yeah. I don't know if that's answered your questions. But more questions? Yeah. Oh, no, yeah, Mike. By the way, the organizers, you just like grab me when you want. Like, one more question. So okay. Make it a really important one. So maybe you make a question, I'll do it quickly, and then another more question. It will be like the most important question you can think of.
Okay, I hope I can keep it short. So what I'm wondering is, say I have an old application now that is based on REST,
Yeah.
I want to edit my profile. For that, I have to fetch the user based on whatever is in the URL. I have to fetch some more data, like what organization does this user belong to. Now I fetch, say, data from 3 REST endpoints.
Yeah.
From your talk, it's not quite clear to me, how does GraphQL solve that actually? It still sounds like some magical incantation in the middle, and then ta-da, here is your data, and you don't need to worry about REST.
Yeah.
How does that work?
Yeah, good question. So first of all, that means that those 3 REST requests will happen on this, like, there's few steps to go. One is first, because the first step is like on the client, you know what you want. So you send it to the GraphQL engine. Let's say the GraphQL engine in the worst case scenario is on your client. That means it's just going to save you a bunch of code on your client. There's no performance gains. Like those 3 REST requests will still call from the client to the server over the wire of your mobile device over the network. Still going to be as slow as before. It's just going to save you a bunch of code. Now let's say your GraphQL engine is in the most, sits down in the most popular place, which is in a server next to your servers, like in a middleware. Then at least the over the network request and response will be just one request with just a limited number of fields. The back and forth will happen inside your server or inside a, let's say, a LAN network. So it would be much quicker. So again, it's like I said before, it's very pragmatical. Every step gives you a bit more performance. Now, let's say one REST request, you see that is slow. Then you have few options. One, inside the GraphQL engine, or the middleware, let's call it, you can start caching it. But you can start caching it on the field level. It's just an easier way to manage it. If you still want to cache it as a REST request, you still can do that. But you have more control because you know what the client needs. Like when you do caching, you do from the server side. You don't know what the client needs, so you cache whatever you think you can cache. On the client, now you have the information on what clients are actually using, which data they're actually using, so when you cache, you have more power. Then let's say, still with the it's a REST request that you still can't cache. Then you can start thinking, maybe I can let go of this REST API. Because what happens in more and more organizations is like, okay, put a GraphQL and gives you like a bunch of performance benefits and much like better tooling and stuff starting to get faster. Then the next phase is like, wait, we have REST API that is calling the database. Why? But it's very pragmatical, so it's not like I'm going to tell you delete all your REST requests now, all your REST endpoints, delete them later when you get there. And more than that, this is something that we start developing now. Let's say you still want, you can get all the benefits of GraphQL, but you still want to expose REST APIs because you have clients or whatever that they don't want to use GraphQL because they're...
Yeah. So,
I just finished the...
Yeah, you just finished the last sentence.
Yeah.
Super.
So what we started building is that you can generate REST APIs from GraphQL. So how do you do that? You just generate the queries. You assume the queries, right? Because that's what you do with REST. And then you expose them as REST endpoints. And then let's say the client comes and says, hey, but I want to change the endpoint like they do with REST. You used to write code for that. Now you can just change the query.
Yeah.
So everyone can start using GraphQL without knowing it. So.
Thank you very much, man.
Thank you.
So, piece of box of chocolate for you.
Thank you.
You're a Goldshtein, everybody. Very nice. So, if people have more questions for him, he will be available for now 10 minutes in the living room on the first floor. Next up will be Leah Veru.